All right, welcome. Today, we're going to tackle artificial intelligence, and we're going to do it from the ground up. We're going to dive right in and turn all that confusing jargon into ideas you can actually get your head around. You know, if you've ever heard terms like LLM or generative AI or neural network and felt like you're kind of missing a piece of the puzzle, well, you are in exactly the right place. We're going to build a mental map together, piece by piece, so you can navigate this whole new world. So let's start with the big one, right? What even is artificial intelligence? The best way to think about it is like a grand blueprint. It's the overall vision, the master plan for creating a digital mind.
At its heart, AI is really just the science of making machines smart. The big dream here is to simulate human intelligence, and that's not just about crunching numbers faster. It's about learning from things that happen, figuring out tough problems, and even making judgment calls. Kind of like how your streaming service learns what movies you'll probably like.
Now, you don't build something that ambitious without some serious building blocks. We're going to focus on just a few of the big ones today: machine learning, deep learning, and neural networks, as we start putting together this digital mind.
Okay, so let's get into the architecture. If AI is the blueprint, then how do you actually build the brain? What's the internal structure even look like?
Well, the answer is this really powerful technique called deep learning. Just picture layering sets of instructions, one on top of the other, creating this super complex, interconnected network. And what's so wild is that this structure lets the system learn and get better all by itself, without a human having to step in and fix every little mistake.
And here is the really cool part. This whole structure isn't just made up out of thin air. It's directly inspired by the most powerful computer we know of, the human brain. Those interconnected neurons in the AI, they're designed to mimic the neural pathways firing in our own heads.
So we've got the structure of a brain, but a brain is pretty useless until it actually learns something. So that brings us to the next big step, the education of this digital mind. How does it go from being an empty box to this incredibly powerful tool?
It all starts with something called algorithms. And hey, don't let that word scare you. An algorithm is really just a recipe. It's a set of instructions. Think of it like a lesson plan that tells the AI exactly what steps to follow to solve a problem.
And this whole schooling process is called model training. It's pretty amazing. First, you feed the model a gigantic library of data. I mean, it's like giving it all the books in the world to read. Then, it starts tuning its own internal connections, finding patterns all by itself. And finally, it works tirelessly to minimize its mistakes, constantly tweaking itself to get closer and closer to the right answers. And when you do this training process on a truly mind-boggling scale, with just massive amounts of text and code, you end up with something called a large language model, or an LLM for short. Think of these as the super-educated PhD-level language experts of the AI world. I bet you've definitely heard of some of these. Models like Google's BERT and Palm, and of course, the now famous GPT series from OpenAI. These are all examples of those powerful, highly trained LLMs. Okay, so our digital mind is built, it's been educated, now what? How do we actually talk to it? This is where all that theory gets real and we actually get to have a conversation. So we do this by interacting with a specific kind of AI called generative AI. And its specialty isn't just looking at data, it's creating something totally new from all the patterns it's learned, whether that's a picture, a poem, or a really detailed answer to a question you have. And honestly, if you've ever played around with a chatbot or an AI image generator, then congrats, you're already a part of this story. You've already had a conversation with a generative AI.
The way we kick off that conversation is with a prompt, and that's just a fancy word for the instructions we give it, using plain old English, asking, "What's the capital of Spain?" or telling it, "Hey, write a short poem about a rainy day." Yep, both of those are prompts.
Now, this right here clears up a super common mix-up. Just think of it like a car. OpenAI is the car company, the one that builds the thing. GPT is the powerful engine under the hood. That's the core technology. And ChatGPT, that's the dashboard, the steering wheel, the app you actually use to drive it. See? Company, technology, and product.
So, we've got these incredible, super smart models that we can just chat with, and they seem to know everything. But what happens when they get something wrong?
Are they always right?
And that brings us to our last and honestly most fascinating section, the imperfections. Because even the smartest digital minds can make mistakes. Sometimes they hallucinate.
So what is an AI hallucination? It's when the model confidently tells you something that is just plain wrong. It might make up facts or get details completely backward or even cite sources that don't exist. And the tricky part is, the answer looks totally realistic and plausible, but it's not actually connected to reality.
Now, it's so important to get this straight. This is not like a human hallucination. For an AI, it's not a sign of consciousness or that it's thinking. It's a system error. It's like a mathematical hiccup where the model just connected the wrong patterns together. It's a flaw in the technology, not a feature of a mind.
And that kind of leaves us with the really big question, doesn't it? We've built this digital mind, we've educated it, and we've learned how to talk to it. We've seen how powerful it can be, but we've also seen its weird flaws. So the real question for all of us is, as we move forward, how do we learn to trust something that is so powerful and yet so imperfect? That's definitely something to think about. Thanks for joining me for this explainer.